What is memory? It's quite a wide subject. Our goal is to cover the basics of memory for the purposes of data structures and algorithms. Let's think of our computer here as an example. What's the main goal? To access, manipulate, and store data, right? So when I say data, say it can be a presentation, Excel file, email, etc. We have multiple resources for this. RAM, which is the memory, which is the topic of this class, and hard drive and/or solid state drive. So why do we have both units when we can just have one? Short answer, RAM is temporary but fast. Hard drive solid state drive is permanent but relatively slower. So let's give an example of a woodworker. Say that this woodworker Joe has two places. One is a home studio where he works on his products, and the other one is a store where he sells the products. So in between these two locations, he has 2 miles. Each product takes a week to finish. So does it make sense for him to bring back and forth every day the products from home to the store, store to the home? No, right? He needs fast access. But it will be a temporary location. So when he's finished with the product, he will bring it to the store. It will be a slower access for him, but it will be a permanent location. Similarly, when you are, say, working with a PowerPoint presentation and you forgot to save it and your computer restarted, you cannot find your recent changes, right? However, if you saved it before your computer started, your PPT will be living here. So now that we cleared away the main purpose of memory, let's understand what language she speaks. So she speaks a binary language. So in binary system, we explain the data with zeros and ones. Simple enough. Either 0 or 1. So let's think of your organizers at home, cube organizers. So I will draw a similar shape here. So say that these are our memory slots that we are trying to store the data for. So I'm gonna take one of these cubicles here to explain. So say that this is my cubicle. This cubicle, each one will be a byte. And 1 byte includes 8 bits. So when I store a 32-bit integer, say in this case, for example, 1, where do I store this 1? So first of all, we have to always remember, like when we are writing on a page, where do we start writing? We start writing from the left side, right? So similarly, what we will do is we will go to the left of this page, so-called memory slot, right? So we will be placing our number 1 here if this is available. So, but keep in mind, this is 32-bit, excuse me here, let me correct this, 32-bit integer. So for a 32-bit integer, we have to allocate this entire 4 memory slots. So how will it look like this? So I'm going to take this 4 memory slots here and then try to replicate them here. 1, 2, 3. So this one will have 8 bits, right? So it will be looking like 1, 2, 3, 4, 5, 6, 7, 8. So where does this number 1 go in a binary system? In a binary system, this will be all multiplied by 2 to the powers. 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and so on. So in order to make this 8-bit structure number 1, what do? I put my number 1 here, right? 1 times 1, it will be 1. So the remaining will be zeros in this case. So I just wrote my first slot. Well, what about the second one, right? So the second one will continue just next to it. 1, 2, 3, 4, 5, 6, 7, 8, right? So let's fill this one. Since we already represented our number 1 that we wanted to find a home for, these will all take number zeros. And then for this one, same thing. For this one, again, same thing. So you got the point. So the idea is if this is a 32-bit integer, we allocated this entire row here. Okay, so when this is 64-bit integer, what will we do? It will be a much longer case here that we will have to fill.